Today, we would like to be able to do differentiation in a different manner. We're going to do implicit differentiation. So to help understand the difference between explicit and implicit differentiation, I'll give you an example of explicit equations. Equations that are solved for a single variable. For example, y is equal to 2x squared plus 1. No problem finding that derivative. Agreed? Or say you have y is equal to secant squared of 4x. Now, a little bit more difficult, right? But we've talked about how to do that. Y is equal to the square root of 9 minus x squared. That's actually the graph of a semicircle. It's the top portion of a circle centered at 0, 0. That is a radius of 3. Okay? So what about all the other types of things? Examples of implicit equations. Implicit equations are ones where you don't have y directly solved for. So for example, 2x plus y is equal to 1. Now you would say, no big deal, Mr. Gens. I'll simply subtract the 2x over, and then y will be solved for. Okay, well that's great. Well, suppose you have, say, xy is equal to 4. So now it's x times y. But now you're still saying the same thing, like, well, I'm just going to divide by x, Mr. Gens. Okay, so what if you have this then? Xy is equal to sine of xy plus x minus y. So are you really going to try to solve for y in that scenario? No, you're not. And so we come up with needing ways to find derivatives even when we don't have y directly solved for. So this means the derivative of a function with respect to x. Okay, the derivative of f with respect to x. So x is your variable. It's your independent variable in that situation. And that's what we've been doing so far. Okay. This means the derivative with respect to x. So it's not necessarily the derivative of something else so much as just the derivative of that thing. And this one is very similar to the first one, the derivative of y with respect to x. Now, the difference is that y may not represent a function in this scenario. So, for example, x squared plus y squared is 9. That's a circle centered at 0, 0 with radius 3. So we can still examine the derivative of y with respect to x without naming it as a function. So you can see they are similar, but they are different. So I'm only going to do this once. Okay, you will not have to do this again, but I'm going to find the derivative of x squared plus y squared equals 36 using implicit differentiation. Okay, all right. Implicit differentiation, we'll show you what that means in a second here. So I have the derivative with respect to x of x squared plus y squared is equal to 36. Can somebody tell me what's the derivative of x squared? 2x, okay? Can somebody tell me what they feel the derivative is of y squared? 2y. And what's the derivative of 36? Yeah. So we're not quite right with that, okay? And it's just something very small, but I want to make sure that everybody understands this piece. Suppose I have y is equal to 2x plus 1. Can somebody tell me what y prime is? 2. Everybody on the same page there? So that means that if I rewrote this as negative 2x plus y is equal to 1, I should come up with y prime equal to 2 as well, correct? So just watch what happens. What's the derivative of negative 2x? Negative 2 plus What's the derivative of y? It is, but look, you end up with a y prime, don't you? It's actually 1y prime, okay, is equal to, and what's the derivative of 1? 0. So you see how you end up with y prime is equal to 2? You see how we have to come up with a way of coming up with that y prime? So I'm going to show you where that y prime comes from. This is you don't have to repeat this. This is just your chance to understand what the heck is actually happening. Okay? So watch this as I roll through it again. You said 2x, and you are right. Notice that when you take the derivative, the power reduces from x squared to x to the first, correct? We like to say that that's absorbed by dx over dx. Plus, you guys told me the derivative of y squared is 2y. What happened to the power? It was reduced, correct? So I'm going to take that one power and attach here dy over dx is equal to, and you told me that was 0, correct? So what's dx over dx? 1. So see, you have 2x plus 2y times. Do you know what? Do you know how you can rewrite dy over dx? That's just y prime. Our goal is to solve for y prime. Could you now solve for y prime? Yeah. You have 2y, y prime is equal to negative 2x. Divide both sides by 2y, and y prime is negative x divided by y. So the rule of thumb is this. Whenever you take the derivative of something that involves y, attach a y prime to it. If you're wondering why, you got to look back at this and work it through. Let's not fill that out. You guys are far too intelligent in class. We can just do it. Let us find the derivative using implicit differentiation. What's the derivative of 3x squared? 6x minus, what's the derivative of 4y? Close. 4y prime equals, what's the derivative of 4x? 4. I solve for y prime. Negative 4y prime is equal to 4 minus 6x. Divide by negative 4. Y prime is 3 halves x minus 1. Everybody is correct, because I know many people are thinking, Mr. Gans, couldn't you just solve for y and then take the derivative? Yes. I'm showing you an alternative way of doing it. That would not work for example D. Okay? All right, letter B. Derivative of y cubed. 3y squared y prime minus 5 plus 2y prime equals 3. Oh no, I have more than one y prime. Okay. Riker sees it. He recognizes it. We prepared you guys last year for this moment. You have 3y squared, y prime, plus 2y prime is equal to 8. He says gather all the y primes on one side. Then to isolate the y prime, we factor it out. You remember me teaching you that last year. It was for this moment, so that when you would do it, you know what you're doing, you would have success. When we factor it out, we can then just divide. Y prime is in fact 8 over 3y squared plus 2. You try letter C on your own. Ready, set, go. When you're done, compare with a partner, see what they got. Maddie? I saw the eyebrow raised. You're good? Okay, all right. Okay, I have 9x squared minus 1 over 4y minus 16y cubed. Is that correct? So is that the same thing as 1 minus 9 squared over 16y cubed minus 4y? Or are they not the same? Are they equivalent or no? They are equivalent because the top and bottom are different by a factor of -1. Now, I want to be clear. 1 minus 9x squared, that is the difference of two squares. You could rewrite as 1 minus 3x times 1 plus 3x. There's no point to factoring unless you see something's going to cancel. So factoring is not necessarily more simplified unless you're going to be able to combine some like terms or something else, okay? All right? that was what we call an overreaction. Okay. All right. So you have the basics. Let's step it up, and I would say that so I've done all the AP tests, the multiple choice questions from back to 1965, and every single one that I see has this kind of a problem on there. Okay, so don't. Sometimes I think you see a little bit more difficult. You're like, what do I really need to be prepared for? Yes, we need to be able to do this. What's different about this situation? X and a Y. Thoughts? Product rule. Very good. I'm going to take the derivative of 3xy. So I will call that f, and I will call this g. What is f prime? 3. What is g? Y. Plus 3x y prime. So that's the derivative of 3xy. Everybody clear? That's the product rule using 3xy. Plus 9 is equal to 10y y prime. And now we operate just like normal. 3xy prime minus 10y y prime is equal to -9 minus 3y. Factor out that y prime, and I get 3x minus 10y. So -9 minus 3y. Y prime is -9 minus 3y over 3x minus 10y. Or you can factor it so that it's 3y plus 9 over 10y minus 3x. So the AP exam will often have multiple representations. Make sure that you choose the right one. What do you think? Okay, so let's go back to our basic question, which is write an equation for line tangent to the curve of the given point. Who can tell me what kind of a shape this makes right here? It does make a circle with a radius of the square root of 625, which is 25. Everybody agreed? So which quadrant is that point? So it's going to be somewhere down here. So somebody tell me something about the slope. It's going to be negative, and it looks like its absolute value is probably less than 1. Would you agree? So I'm trying to get a reasonable assessment for my answer. I know what the graph looks like. Do you know what this graph looks like? No, I don't either. So when you have the opportunity to view it to check your answer. So here we go. I need to find this derivative. I need a slope and a point. I have the point. The point is -7, -24. Now it's time to find the slope. How do I find the slope? Derivative. Derivative of 2x squared is 2x plus equals settle. 2y, y prime is equal to -2x. Divide by 2y. Y prime is -x over y. So the slope is -x divided by y. So what do you think I do? I plug in -7 for -x, and I get 7 over -24. So you told me that the slope should be negative, which is correct, and we said its absolute value would be less than 1, which it is. Can I trust you that you then know how to write the equation for the line? So let's move to our last one. slope, and a point. I have my point, which is 1, 1. Need to find the slope, so I take the derivative. Derivative of x squared is derivative of 4xy. Product rule. Derivative of 4x is 4 times y plus 4x times y prime minus 4y y prime equals 0. Now, folks, it does not tell me to solve for y prime. I'm simply just going to plug in 1 for x and 1 for y and use it to determine my slope. So 2x becomes 2. 4y becomes 4. 4xy prime becomes 4y prime minus 4y prime, which is equal to 0. So you can see you get 6 equals 0. What do you think that means? The slope is undefined. There is no slope. So what kind of equations have slope that's undefined? Vertical lines have an equation of x equals. It's a vertical line of x equals. Right? Okay, because you have 4 types of slope, right? Positive, negative, 0, and undefined. This one is coming out as an undefined piece. So x equals what? What's the point it passes through? So you use the x value of 1, so you get slope is undefined. So x equals 1 is your tangent line at that spot. There you have it. Good job, folks.